This is Sharma solution, class 12, chapter 2, functions. Exercise is 2.1. This is question number 6. If f function is from a to b, so f function is from a to b, is an injection such that range of f is equal to a. So the range is only a injection. Determine the number of elements in a. Injection means 1 to 1. That is one element of a is related to one value of b. A is one set, b is another set. Range is only a. And since it is 1 to 1, there has to be only one element in the set a. Okay? So how many numbers of elements in a? Only one, because it's 1 to 1. A is only 1. Question number 7. Show that the function f, the function is given like this. F is r minus this 3. So all real numbers without 3 or ignoring 3. Then we have function a to b. For example, a is given here r minus 3 and b is given as the codomain is all the real number except 1. Denying 1. Right. And the function itself is x minus 2 by x minus 3. So you have to show that this function is a bijection. Remember, this is a CBSE 2012 NCERT important question. 1 to 1, on to, both we have to prove. So first thing what we do, always 1 to 1 is simply say fx equals fy and we have to prove x is equal to y. If we can prove x equal to y, then it is done. Okay. So we have x minus 2 divided by x minus 3 fx, and for fy it is y minus 2 y minus 3, and then just cross multiply. When you cross multiply, you'll see, I'll just show you here because you know how to cross multiply. So all these will be cancelled, only x and y will remain, because you see minus 2y and minus 3y, they will give you y, and negative 3x, negative 2x will give you y. So ultimately you will get x equals to y when you started with fx is equal to fy. So this is what we wanted to prove. So when fx equals fy, x equals y, that is, it is 1 to 1. So we checked 1 to 1, we checked the injectivity or 1 to 1. Now second part, we have to check the surjectivity or onto, that whether this is onto or not. Onto, what do? We just write fx equals y, and then we try to show that x for x is a valid value, because for y there will always be some value in the first set, which is called the pre-image. X minus 2 by x minus 3 equals y, so just cross multiply it. So when you cross multiply, you know how to do this. So let me just come to the point. I am taking x on one side and everything on other side, that is y on the side. So x in terms of y. So whatever you get, I'm just writing it here. X equals 3y minus 2 by y minus 1. What do you see here? Now, this is x and y, that is domain and codomain is given. So what do you see here? 3y minus this is, you are getting proper value of x for every y. But what happens when y equals 1? Whatever comes in the numerator, it will be 0 in the denominator. So it will fail. But if you see the codomain very carefully, they have already given it's r minus 1. So you cannot put 1. So now it is valid. Only 1 you cannot put, otherwise everything you can put. So r minus 1. So this is 1 1 also, this is onto also. Next one is question number 8. Show that function f r to r, and this function is given as real number to real number, and this is given by fx equals x minus, and this is greatest integer function of x, is neither 1 1 nor onto. Neither 1 1 nor onto. So you need to know about the greatest integer function. I already discussed in theory. Okay. This question, as I said, it is CBSE. It has already come in 2012 and NCERT, so it's an important one. Okay, so f, as I said, it's r to r, and this is x minus this. Now greatest integer function is the integer value which is lower than the decimal value or the fraction value. It's very clear and very obvious also, because by observation we'll do. This is a real number 9. So because it's a real number, 0.2 will come, 0.8 will come, negative also will come. So for checking integer, just check for integer. 1 minus, and greatest integer function for integer will always be integers. 1 minus 1 is 0. You check for 2. So 2x is 2, and greatest integer function of 2 is also 2. So 2 minus 2 is going to be again 0. So what do you get? It's 0. But what about 2.2? What about 2.4? So here, whenever we put an integer, what do we got? Whenever we put 1, you get 0, 2, you get 0. That is, from just checking 1 and 2, we got this, that it is not 1 to 1. From just 2 checking, it is not 1 to 1. Clear? Now let us come to the surjectivity. And x minus greatest integer of function of x. Let me put the decimals value, actual values now. So in x I'm putting 2.1, and in x you have to put 2.1. So 2.1, what is the greatest integer value of 2.1? So 2 is the floor, 3 is the ceiling. 2.1 greatest integer function is the ceiling, the floor function. So it will give you 2. 2.1 minus 2 will be 0.1. So 2 minus 2 is of course 0. So it starts with 0. It goes to 0.1, and all the values between 0 to 0. It will never reach 1. Actually, it is between 0 and 1. If I am putting 2.2 minus greatest integer function of 2.2 is 2. So you get 0.2. So 0, 0.1, 0.2. So let us take 3 also. So you'll again get back to 0. So what I'm trying to suggest here is, all the values which are put, the range will always be between 0 and 1. It will always be between 0 and 1. There will be no value beyond this. You can check for any value anywhere, because this function is like that. So 0 and 1 is not inclusive. It will never come 1. 0 is inclusive. Okay, so this is whatever you take. In the domain, it will be all real number. In the range, it is again all the real numbers. But what do you see here? All the real number is the codomain. If you see the function r to r, this is all codomain. But the range is only 0 to 1. 1 is not inclusive. So in onto, what do we check? In onto, we always check that the codomain should be equal to range. But they are not equal here. When they are not equal, we say it is not onto. It is not 1, not onto. Now question number 9. So we have a function. So the function is, let f n to n be defined by. So please remember, domain and codomain both are natural number. So we cannot have a 0 here. We have to start with 1. The function is n plus 1 if n is odd, and n minus 1 if n is even. N plus 1 if it is odd, and n minus 1 if it is even. How do we do this? Okay, we have to prove that it is bijective. So 1, 1 and onto. Let us check for 1, 1 first. Then we'll check for onto. So this is fx equals fy. Then we can prove that if x equals to y, we will say just okay, that this is 1 to 1. Since we have multiple functions here, means for everything things are changing. So we'll take the cases. X and y both can be even. If fx equal to fy, x and y both can be odd. X can be even, y can be odd, x can be odd, y can be even. So there can be 4 combinations. So one by one, I'm going to take the combination. You can also take in place of x, you can take n1, and in place of y, you can take n2. It's just same, x and y, n1 and 2. It's up to you. Now if n1 is odd and n2 is even, first situation is this one. So if n1 is odd, just assume this is fx and fy only. So f n1, what is odd? N plus 1. So n1 plus 1 you will get here. N1 plus 1. What about this one? If it is even, it is even, you will get n minus 1. So n is even, so you get n2 minus 1. The second function will work. n1 plus 1 equals n2 minus 1. So just change the positions here. n2 minus n1 equals 2. Is it possible when number 1 is odd, 1 is even, is it possible the difference is 2? For example, you take 2 and 3. 3 minus 2 is 1. So this is wrong. It can never come. Not possible. Now take n1 as even and n2 as odd. Same situation. So what we'll do? When n1 is even, you'll get fn1 equals fn2. This is n1. So this is even. And this is odd. So this is even. Even you get n1 minus 1 and odd is n2 plus 1. Same scenario. Just here n1 minus n2 equals 2. So this is also not possible. If 1 is odd, 1 is even, then the difference cannot be 2. I'll just take one more example. 2 and 5. 5 minus 2 will be 3. It will never come 2. Even never it will come. So these two conditions fail. So x and y has both should be even or both should be odd. How to do this? Now we are assuming the third condition, even, and then we'll go to odd. So we are assuming n1 and n2 both, or x and y both are even. So n1 is even and n2 is also even. So for even we'll take n1 minus 1, here also n2 minus 1. So you can just remove this 1, you will get n1 equals n2. So this is what wanted. If fn1 equals fn2, n1 equals to n2, that means it is 1 to 1. Let us check for the final condition also. fn1 equals fn2, and we are saying n1 equals odd and n2 equals odd. Both are odd. So now first equation we'll use. n1 plus 1 equals n2 plus 1. 1 gets cancelled, n1 equals to n2, and this is what we wanted. fx and fi. So first two condition fails. But two conditions which are possible, here it is 1 to 1. Let me clear it now. Now the second part, 1 to 1 we have already seen. Let us check for the surjectivity. That is onto or not. Surjection means what? We write fx equals y. And we prove that every value of y will have a value of x, proper value of x in the domain. So every y in the codomain will have a unique value, or you can say a pre-image in the first set. So fn is, the function is fn equals n plus 1 if n is odd, and n minus 1 if n is even. Right. So what do we do? We will, two cases we have to take. Same thing we'll do for two cases. fx equals y, same here also. Fx equals to y, and we have to prove that for every value y, it will come only with some x, which is a valid x, because it is n. So let us say it n, it doesn't matter. Fn equals y, fx, fn, it is same thing. Fn equals y. Now we are taking first as the even case, second as the odd case. How about being even? When n is even, what will be fn? Fn is even. So even means n minus 1 you have to write here. N minus 1 equals y. And from here, if it is odd, what will come? N plus 1. N plus 1 will be equal to y. But you will say you haven't done n as even and odd. So you have to make it as even and odd. So n equals 2r is a general condition for n to be even. And if you write this n as 2r, please remember in natural number, this 0 will not come because the function is from n to n. And I am putting as 2r. For this is a general way of writing any number as even or showing it. So 2r minus 1 equals 1. How to make it odd now? N will be equal to 2r plus 1. R you put any value. You put r as 1, you will get 2 into 1 plus 1, that is 3. You put r as 2, 2 into 2, that is 4 plus 1, 5. So this is how, this is generalized way we are writing. So 2r plus 1 equals y. Now you see here, y equals 2r minus 1 and y equals 2r plus 2. Every y has a unique r. That is, there has to be some specific r or x that you put, then only you get a y. Similarly, in here also, you have to put certain specific value of y, valid value, which will give you y. So this is a valid equation. Both the equations are valid, for which y is also defined and r is also defined. I'm not putting it as x because we just replaced x by n and then we replace n by r. So you can assume r as x only. Okay, this is bijective now. This is question number 10. Let a equals 1, 2, 3. Write all 1 to 1 from a to itself. So this question, it will be again remembered in question number 14, 15, 14 and 15. So please watch it very carefully. So f is from a to a. This is 1, 2, 3. This is 1, 2, 3. So 1, 1, 1. We are making 1, 1. 1, 1, 2, 2, 3, 3. So this number of possible are factorial 3. That is 3 into 2, 6. The second one, 1, 2, 3. 1, 2, 3. Now 1, 1, 2, 3, 3, 2. This one. Next one. Let us take two more. Any of these. Let me tell you, number of elements are 3. So the total number of 1 to 1 functions will be number of ways of arranging 3 elements is factorial 3. That is 6. I'm taking one more. 1, 3, 2, 1, 3, 2. How many of these? 6, 1. So all others you can make. This is the answer. Question number 11. If f is from R to R, for the competition people, this is very important because the range and domain is very important here. Range, domain, codomain. So the function is defined by fx equals 4x cubed plus 7. Show that f is a bijection. So for bijection, we have to prove that it is 1, 1 also and onto also. Okay. So this is this has come already in this CBSE 2011. So 1, 1. Let us check for 1, 1. Fx equals fy. So we have to prove that x equals y. So fx equals fy. 4x cubed plus 7 equals 4y cubed plus 7. This gets cancelled. Divide both sides by 4. You're getting x cubed equals y cubed. So you get x equals y. Because whenever there is even, you get x equals plus minus y. But when it is odd, I told you already, x will be equal to y. So this is 1, 1. Because if fx equals fy, if you are able to prove x equals y, then this is 1 to 1. Now coming to the second one, which is onto. What do you do? Fx equals y. Then we try to put x in terms of y. Then we try to show that every y has a x. So fx is 4x cubed plus 7 equals y. Now I'll put it here. 4x cubed will be y minus 7. X cubed will be y minus 7 by 4. X will be, let me write it here. X equals third root of y minus 7 by 4. So because third root, there is no problem. I told you that to the for all real number it is known and it has a valid value. So this is onto also. For every y there will be x, or for every x there will be y. So for every y there will be a pre-image which is x. Okay, this is e to the power x and next question is log x. So we'll do it in the later discussion. And then thank you so much. Take care of yourself.